My video about Apple quietly winning the AI race got a really strong response. Some people agreed, others didn't. But thank you to everyone who left a comment to share their insights. When I went through the comments, I realized that the main reason why people disagreed was that Apple signed the deal with Google to put Gemini in Siri. And to many people, that's Apple admitting defeat, waving the white flag and handing the AI crown to Google. And if we're talking just about LLMs, then I would say fair enough. That's a completely valid argument. But I realize that people might be confusing LLMs with AI. LLMs are not AI, they're a type of AI. So in this video, I'd like to take you through 6 decades of brilliant ideas, spectacular failures, and the breakthroughs that got us here, and explain what AI actually is. And look, after that, people might still feel that Apple has been left behind, and that's completely valid. But as I'll explain, the limitation with AI is not necessarily the software, but the hardware that it requires. If I asked you to define AI right now, you'd probably describe something that talks about a machine working like a human. But that's like describing the ocean as something you can surf on. It's true, but it's incomplete. AI is actually any system designed to do tasks that we associate with intelligence, learning from experience and recognizing patterns, understanding speech, planning, and making decisions when you don't have all of the available information. But notice what's not in that definition: chatting and conversations. Those are part of AI, but they're not the core function of AI. Over the last few decades, this field of AI has gone through some massive optimism and crushing disappointments, along with some really genuine breakthroughs. But they're usually driven by 3 things colliding at once: new ideas, more data, and most importantly, better hardware. So while Apple did ask Google to power Siri, that's by no means admitting defeat. In the 1960s, scientists thought that they could build a thinking machine in about 20 years. Turns out they were hugely optimistic. Early AI researchers had the idea that human intelligence is basically just reasoning. It's a series of logical steps. So if we could write down those steps and program them, voila, we have a thinking machine. And this is what we call symbolic AI. But they all kept falling into the problem that everything broke when somebody asked a question that wasn't in the predefined set of rules. So these systems broke all the time, and computers of that era didn't have the speed or the memory to handle the real world messiness. And the researchers started to realize maybe intelligence just isn't just logic after all. By the 1970s, the approach had shifted. Instead of trying to build general intelligence, researchers narrowed the focus on expertise. The idea was that they would interview doctors, engineers, geologists, specialists in their field, and capture their knowledge as a whole series of if-then rules. If the patient has this symptom, then this could be the diagnosis. If the rock looks like that, then drill for oil here. These were expert systems that worked in very limited domains, and some of them were really, really useful. But maintaining them was a nightmare. You ended up with thousands of rules, hundreds of exceptions and overrides, and every time the real world changed, like a new disease or new discoveries, humans had to manipulate and update all the rules manually. So these systems were really brittle. They couldn't learn and they couldn't adapt. And when the expectations didn't match the reality, the funding dried up and the media moved on and researchers couldn't get grants. This is what people call the AI winter, a period when all the hype collapsed and the world went really quiet. In fact, there were 2 major winters, one in the mid-70s and the other one in the late 80s, and both followed the same pattern: overpromise, underdeliver, lose people's trust. But what people probably don't realize is that during those winters, there was a small group of researchers who kept working on different approaches, and one of those would eventually change everything. So what if instead of telling computers the rules, we showed them millions of examples and let the computer figure out the rules itself? That one idea is why you have AI in your pocket right now. So the core insight was this: stop writing rules and start showing examples. This is machine learning. Instead of programming that a cat is an animal with pointy ears and whiskers, you show the system thousands of cat photos, and it starts to learn the patterns statistically. It figures out what catness looks like. even if it's never seen a specific cat before. You know those Google image checks where you click on all the buses or traffic lights? That's reinforcement learning. And Google's AI already has a pretty good idea of what those things are. It's checking its knowledge against yours. And this approach scales much better. It adapts to messiness and it improves the more data you feed in. These are neural networks. They're computing systems that are inspired by the brain. Actually, they've been studied since the 1950s, but they kept on hitting walls. The wall was the compute power. There was not enough compute, there was not enough data, and the training methods didn't really work. But piece by piece, these problems started getting solved. Better algorithms for training networks, and the internet came along and produced a vast amount of training data. And more importantly, the hardware breakthroughs that nobody saw coming. The technology that made modern AI possible was originally designed for video games. So in 2012, something remarkable happened. A neural network called AlexNet crushed the competition at an image recognition challenge. It wasn't by a little, it was by a vast margin. And their secret weapon was graphics processing units, or GPUs. GPUs were built for video games. They're designed to do tons of simple math operations in parallel, calculating millions of pixels every second. But it turns out that training neural networks is also a ton of very simple maths run in parallel, matrix multiplications over and over billions of times. So GPUs were accidentally perfect for AI. So suddenly researchers realized that they could train much bigger networks much faster. The image recognition accuracy jumped enormously. Speech recognition got much better, and machine translations actually started working. And this is when AI stopped being a research curiosity and started becoming something that you use every day. Voice assistants, phone tagging, recommendation systems, search results powered by deep learning, all trained on GPU models. One research paper in 2017 changed the entire trajectory of AI. It was called Attention is All You Need, and it really was. By the mid-2010s, vision and speech were improving quickly, but language was still hard. Previous approaches processed text one line at a time in order, and that was slow, and it struggled with documents where meaning depends on contexts from different parts of the document, like contracts or instructions. So then in 2017, Google researchers published a paper introducing the transformer architecture. The key innovation, well, instead of processing sequentially, the model looks at all the words at once and learns which ones are important to each other. This made it practical to train absolutely massive models in enormous amount of text data. Large language models, or LLM, learn by predicting the next token in a sequence. It sounds simple, almost like autocomplete, but scaled up and trained on all the text on the internet, something really interesting happens. The models start to learn grammar. They learn writing styles. They learn facts. They learn reasoning patterns. They learn how to write code. They learn how to answer questions, and they learn to have conversations. OpenAI brought this into the mainstream in 2022 with ChatGPT. And suddenly millions of people were experiencing firsthand what AI could do, and it felt like magic. But here's where I need to push back on the common narrative. ChatGPT is impressive, but if you think ChatGPT is AI, you're missing out on 90% of the picture. An LLM is a generative language model. It's brilliant at producing and transforming texts, conversations, summaries, code, translations. But most AI systems aren't chatty at all. And right now, AI is being used to solve all sorts of problems that you may not be even aware of. Your banks are using AI to detect fraud in your credit card transactions. YouTube is predicting what you're going to be most interested next when you watch a video. Businesses are using AI to forecast inventory for supply chains. People are starting to use AI to diagnose diseases from medical scans. And of course, we're still trying to do driving cars and do robots and optimize energy grids and discover new materials and drugs. And none of that involves conversations, and none of that is ChatGPT. But language is one interface to intelligence. It's an important one. But intelligence also means perceiving, acting, and reliably achieving goals in the physical world. Language is one interface to intelligence. It's an important one, but it's not the only one. And so if you think of AI just in terms of chatbots, you're looking at one branch of a very, very large tree. GPUs made AI possible, but they're power-hungry beasts that live in data centers. And the next wave of AI, well, I believe it's going to be happening in your pocket. So there's more than one twist in the hardware story. Neural engines, sometimes called NPUs. If the GPUs are the heavy construction equipment required to build massive models in data centers, neural engines are the efficient motors for running models on your device. They're designed for low power consumption and fast inferencing, which means getting answers quickly without killing your battery. And that's why you're seeing more and more AI features happening locally. Real-time transcription, photo enhancement, on-device translation. That's really important for privacy because your data doesn't have to leave your device. It matters for speed because there's no round trip to a server, and that matters for access because it works even when you're offline or out in a remote area. The future isn't just bigger and bigger models in the cloud. It's also smaller and smarter models running everywhere. So here's the takeaway. So there's no doubt ChatGPT is a major milestone, a genuinely impressive one. But AI is much bigger than ChatGPT, and it's much bigger than language models. AI is a toolbox. It's learning, perceiving, reasoning, and actioning. This field has been through hype cycles and winters before. It's been declared dead multiple times. And yet here we are with AI embedded into almost everything around us, most of which is invisible. The question isn't whether AI will change things. It already has. The question is what comes next. So when I say that Apple is winning the AI race, I say that because of its hardware capability. Now, you might still argue that Google is winning on cloud AI, but they're not winning on device, and that's where I believe things will go. So if this has helped you understand AI better than the usual hype, please subscribe and I'll keep breaking down the stuff that actually matters.